Hello students, welcome to the next lecture of the DBMS. Today we will discuss about the concurrency control. So now let's talk about what we mean by concurrency. Basically concurrency means whenever we can perform multiple transactions simultaneously and on same data. So this is a multi-programming environment concept where more than one transactions are executed simultaneously. So in a multi-programming environment where multiple transactions can be executed simultaneously, it's a highly important to control the concurrency of the transactions. Otherwise, this concurrency may lead to the inconsistent database. So we need to control this concurrency. For example, let's say we have a data set where a person has its account in the bank and more than one transactions are trying to write the balance of the account at the same time, and one transaction is trying to update the balance as 5,000 and the other transaction is trying to update the balance as 7,000. So concurrent execution of these transactions may lead to the inconsistent data. May actually the balance would be 5,000, but it is possible that the database showing the balance as 7,000, so it may lead to inconsistency. So we need to perform the control for such type of concurrencies. Now to control this concurrency, we have two protocols. One is known as the log based protocols and other are timestamp based protocols. So let us first discuss the log based protocols where the database equipped the mechanism by which any transaction cannot read or write a data until it acquires an appropriate lock on it. So before you perform any operation on the data, any transaction, if wishes to perform any operation on a data, it needs to first apply for a lock. So now the locks are of two types. One is the binary lock, another is a shared lock. What is a binary lock? A lock on a data item that can be in two states only. Either the item is locked or the item is unlocked. So the lock state says that if a transaction T1 has logged a data item for any operation, let's say reading or writing, so till that transaction is acquiring the lock on that data item, no other transaction can perform any operation on the same data item. So the other transaction will be allowed to perform the operation on the same data item whenever the previous transaction T1 releases the lock. So it's pretty simple. Whenever the transaction wishes to perform any operation on a data set, first it needs to acquire the lock, and after performing the operation it must release the lock so that other transaction can also perform the operations on that data item. So that is a binary lock. Now the other types of locks are shared or exclusive locks. So the type of locking mechanism differentiate the locks based on their uses. If a lock is acquired on a data item to perform a write operation, it has an exclusive lock. Allowing more than one transaction to write on the same data item would lead the database into an inconsistent state. And on the other hand, if the data item wishes to, if the transaction wishes to read the data item, then it applies a shared lock. So there are two types of locks. One is the shared and other is the exclusive, depending upon the type of operation. If the transaction is to perform a write operation, then it has to apply for the exclusive lock. In that case, no other transaction can perform the write operation on the data or read operation on the data. But on the other hand, if a transaction wishes to perform a read operation on a transaction, then it can acquire a shared lock. In that case, the other transactions can also read the same data set simultaneously, but yes, obviously cannot write. So on the case of reading, it's very simple. Let's say if we read a newspaper at the same time, two people, three people or four people can read the newspaper. But if we are writing in a copy, in that case only one person is advisable to write in the copy. So the writing operation is supported by the exclusive lock, and the reading operation is supported by the shared lock. So these are the two types of locks, binary locks or shared or exclusive locks. Now there are four types of lock based protocols. Let's talk about these protocols. One is the simplistic lock protocol, where the protocols allow transactions to obtain a lock on every object before a write operation is performed. Now the transaction may unlock the data item after completing the write operation. So it is one of the very simple lock protocol. That means a transaction wishes to write on any data set, it has to apply a simple lock. But there is no lock is required for the reading operation. The next is pre-claiming lock protocol. So now this pre-claiming lock protocol says the pre-claiming protocol evaluate their operations and create a list of data items on which they need locks. Now, before initiating an execution, the transaction requests the system for all the locks it needs. If all the locks are granted, then transaction executes and releases all the locks when all its operations are over. And if all the locks are not granted, then the transaction rolls back and waits until all the locks are granted. So this is a pre-acquisition phase. So let's say a transaction T1 wishes to operate on 3 data sets, and it wishes to have 2 read operations and 1 write operations. So before it starts its execution, it needs to acquire locks for all the operations, for both read operations and for 1 write operation. And once it acquires all the locks, then it start execution. And once it completes its operations, let's say it completes its reading operation, then it releases the reading lock. And if it does not get all the locks together, so it will not be able to perform its execution. So this is the this is the pre-claiming lock protocol. Now the next, and this is one of the important stage also, that is two-phase locking, is also known as 2PL, where the locking is performed into 2 phases. One is called as the acquisition phase and other is called as the releasing phase. So now it divides the execution phase into 3 parts. One, the lock execution part, the other, the execution part, and the third is releasing part. So in the first part, when the transaction starts executing, it seeks permission for all the locks it requires. In the second part, where the transaction acquires all the locks, and as soon as the transaction releases its first lock, the third phase starts, and in this phase the transaction cannot demand any new lock. So in the releasing phase, the transaction can only release the locks acquired by it into the first phase. So it is the releasing phase. So this is a 2PL, 2-phase locking. In the first phase, it acquires all the locks, and in the second phase, or we can say into the last phase, it releases all the locks. The next is strict 2-phase locking. It is similar to the 2PL with one difference, and the first phase of the strict 2PL is similar as to the 2PL phase. After acquiring all the locks in the first phase, the transaction continues to execute normally, but in contrast to the 2PL, it does not release any lock after using it, and it holds all the locks until all the operations are performed and the transaction reaches to the commit point. And once all the operations are done, it releases all the locks at a time, all the locks together. So this is the difference in 2PL and strict 2PL. While in 2PL, the locks are released one by one as their operations are completed, but in strict 2PL, the locks are released all together. So you can identify the difference here. So this is the lock acquisition phase of the strict 2PL, and release, that is the commit phase, where all the locks are released all together. So these are the lock phase protocols. Now we talk about the timestamp based protocols, where the time stamping is performed onto the operations. Time stamping basically is the mentioning the time where on at what time the operation is going to be executed. Or it can be a counter also at let's say key if any operation requires 10 units of time, so it will be mentioned with the counter time of 10 units. So in the timestamp protocol, basically we have three major timestamps. One, the timestamp of the transaction, the timestamp of the reading operation, which is known as the R, and the timestamp of the data item, which is denoted by W. So how the timestamp ordering protocol works? If a transaction T issues a read operation, let's say a transaction issues a read operation, then it checks if the timestamp of the transaction is less than the timestamp of the writing operation, then the operation is rejected. If the timestamp of the transaction is less than or equal to the timestamp of the writing operation, then the operation is executed and all the data item timestamps are updated. So this is the case for the read operation. Remember, this is the case for the read operation. Now let's talk about the write operation. If the timestamp of the transaction is less than the timestamp of the reading operation, then the operation is rejected. If the timestamp is less than the timestamp of the writing operation, then also the operation is rejected and the transaction is rolled back. This is also known as Thomas Wright's rule. And in the third case, otherwise the operation is executed. So we have just seen the Thomas Wright rule. Let's see it once again. The rule states if the timestamp of a transaction is less than the timestamp of the writing, then the operation is rejected and the transaction is rolled back. So this is the timestamp ordering. So these are the two protocols that are used for the concurrency control. That's it for the today's lecture. You can pause the video anywhere you would like. You can read the text and feel free to comment and ask your queries. Thank you so much.